And welcome to the first of two CAD videos that cover general frame analysis and the subsequent design of elements in steel and concrete. Start with CAD's A3D Max, which is our general frame analysis program. Very affordable program, very simple to use, with a variety of users, including structural, civil, temporary works engineers, as well as scaffold designers and house builders. The program can carry out simple elastic analysis, but is also capable of plastic and P-delta. There's no limit to the size of jobs that the program can do. There's no limited versions. We can do 2 to 3 members all the way up to 2 to 3 story buildings or larger. There's also no limit in the number of loads or load combinations. In the following video, we will present how CAD's A3D Max can be linked to other programs from CAD's for steel and concrete design and to CAD's RC for automatic detailing and scheduling of concrete elements. Some of the key features, as mentioned, the program has an intuitive interface. The program is used by a majority of our users who do not require any training, although of course we do provide it if required. Full support is always provided. CAD's A3D Max is easily suited for very simple frames of 2 or maybe 3 members, say, but can equally be used for larger frames, for which we have macros for multi-bay frames, trusses, girders, as well as rectangular and circular grids, so that you can place your columns on there and build the building up from the ground. I've got some images of client projects at the end where you can see what variety of scale of projects can be done. Users can also import CAD files, DXF files, and that's suitable when you've got more complex geometry like some sort of sweeping roof or curved roof. So you could do the roof in CAD and bring that in as DXF, convert it into members, and then put that onto a frame that you've done in 3D Max on its own. So you can combine the two methods together. We've also got load panels. These panels can be rigid or non-rigid. They provide, therefore, a way of restraining panels rather than cross-bracing of old. And they also will allow you to transfer loads from the panels to the frame. They can be wind loads or they could be floor loads. And these loads can be either point loads, line loads, patch loads, or indeed uniform loads. In the following video, I'll also show you that CAD's A3D Max can be linked to other programs like CAD's RC Beam Designer, Steelwork Member Designer, Moment Connection program. So, without further ado, let's get on and show you 3D Max in action. I just want to show you around the toolbars, the interface, look at the configuration options, and a feature here that I've utilized for my own interface, where you can customize your own toolbar. So we're generally looking here at 4 or 5 tabs. You also got the help screen here where you can look for updates, check out what version of the software you've got, also very useful when you're talking to our support. Look at release notes and videos that you're watching now and others that you could look at, user guide and help. But just going from left to right, we've got the modeling. I'm going to show you how this works, but this is just a sort of go round first. This is grids, which you can bring into the screen to put your members on, circular, rectangular, and they can be connected together. We've got some wizards for multi-bay frames, grillages, portal frames, trusses and girders. You can obviously type in individual nodes if you want to and join them up with the mouse. Put in member types, steel, concrete, timber, for instance. There's a variety of materials which we offer you, but you can edit if we're putting in rigid panels for loading up a frame. That's for precast and cladding it, for instance. And also you've got the input for the supports, the members themselves, the panels I just mentioned. We've got the loads and the combinations here too. As you can see, I've got some default values for my template. As you can see here, dead, live, and so on. And in combinations, I've got this set up to Eurocode, so you can see all the combinations. I've got ULS and a set of SLS here. And all the factors have been generated automatically using the combination generator in the program. The other tab that's useful here, apart from importing and exporting files, DXF, and exporting to things like IFC and AutoCAD, you can see here we've got a configuration screen where you can set up factors for arrowheads, loads and so on, colors of things you see on the screen, rendered and so on, fixities and labels, again sizes of text height, messages that you can suppress if you don't want to see them, options for looking at triads, tooltips that we offer you, folders you can set up yourself so you can pick your own directory for your data, and then you can configure the units, some of the defaults, and then the limits that we set up. As I say, this is the other interface that's new. Recently, we've added this facility here. So if you go down to more commands, you can actually go through the main menus that you see above, pick out any of the commands that are displayed here. And if you find you're tabbing frequently and it gets a bit annoying, you can just simply grab it and put it in your main menu here. So all of these I've copied from this side to here just by adding it here. And I've created my own library of very useful little tools that I often use, so I don't have to tab through up here. There we go, that's the user interface. Okay, so let's put some geometry in. There's several different methods. Really, they vary depending on how complex your structure is going to be and how quickly you want the model to be input. I'm going to show you something very basic to begin with, and then increasingly show you more and more tools that we've got in the program. So let's kick off with just putting in nodes and their associative coordinates. So I'm putting in 3 nodes and then just making up some random numbers here, look, for the geometry. So you can see that they're spread over the screen. And once we've got them on the screen, we can number them up just by offering the joint button here. And then we can create the members by just using what we call quick member, choosing a section type, and literally joining up the dots. So from there to there, and from there to there. There we go. And then just end mode. You can see the rendering here. Now, obviously what's happened there is that node 1 has been connected to 2 and so on. That's actually gone straight into the little panel here. So you can see member 1 goes from 3 to 2 and so on and so forth. So that's the sort of thing you'd have to do in the past. Now it's done graphically. We can add the member numbers and the joint numbers there. Something else that it's possible to do, if we've got a member like this one here, you can still play with various types of members if you're not sure what you're actually going to design yet. So you could change that to concrete, or you could change it to timber, up to you what you're doing. You can also vary the pitch, so you can say it's maybe at 45 degrees. Look. You can play with partial fixity, so you can tell the program what degree of fixity it's got connected to another member, very useful in plastic and portal frame and plastic analysis. And then you've got different types of action. So you've got here the option to make that member tension only, compression only, partially or fixed or pinned. So you can have fixed on one end, partial, pinned on the other. There we go. So that's a very simple method of working. So if you're doing a building or you've got some sort of structure with multi-bays and so on, these are very useful for that. The grids, you can bring in DXF, but these are a little bit more powerful and the members snap to them nicely. So we put in the pitch of our bays. You may have 2 at 6 and then the odd one here at 7 or something, so you can have a varying pitch, and same on the in the other direction. Options here for how you define the distances between the grid lines, which way the grid's going, is it horizontal or vertical. And then once you've created your data, just spin it around so you can see it on the screen. Now in the quick member, just now we showed you how you can draw the members from node to node, but if I'm putting columns on here, I don't have 2 nodes. So very useful little trick here. You can put members in with their length in any of these directions. Now vertically is Y, that's therefore the height. This is the section, pinned or fixed, okay that, and then you literally just drop it onto the grid, like so. If you then need to join those up with a rafter member, we can change it to a 305, okay that, and we go across the top. Look, there we go, in mode. So that's created a little goalpost for us. So if you're doing little extensions and so on, that's ideal. These members choosing, they're actually ones I've created already. Always too much time of yours showing you this, but you can see here the library. It includes steelwork, timber, properties. If you're not sure what the section is or it's not a standard shape, you can at least put in the areas and the inertias. You've also got their RC members. These are parametrics, quite quick to generate just by typing in the shape and so on. And then you've also got steelwork haunches. Now these are very useful for portals. In the old days we used to have to create a node at the haunch position, but now they come as one member. So you just put in what the length of the haunch is, how many flanges you want, Here, look, and what the section is, and you create yourself a haunch type. Very useful. And then you've got the material on the right-hand side. But this is another useful feature. It shows you how many of these members are being used. If you want to, you can pick on the member and it will select the members applied with that section from the model. Very useful when you're editing. So if you've got a whole series of columns to do, rather than you have to go around and pick every one, pick the one here from this box and say select, and then go in and you can edit them directly. Another useful tool for maybe editing this particular shape here, we've decided we want to break this up, so we can use this little tool here called split member. You can do it by percentage, but you can also do it by distance. And if you do it by distance and it's not halfway along, you need to know which way the numbering was done, so you know which way is from and to. And go into our menu up here for member direction, you can see the actual members are given an arrow, so that's telling you that the distance along to any nodes you put in, or loads, is given from left to right in this case. So that's quite a useful thing to know. So we go back to the little tool I was showing you. I'm going to just simply split this in half. So we're going to say, okay, pick on this member here, split it by 50% and apply. There we go. And got a node in the middle there now. 50% and apply. There we go. And then we can change the location of the node. So all we have to do is click on it and edit it, or we could just take a look at it, see what the node number is. There you go, it's node 8. And just to show you another method of working, going in here and saying, right, it's got to be 5 meters, not 4. There we go. The other method of producing more and more geometry quickly is copy and paste. So we can window around our frame, go up to modify and just use copy, paste. And we can put in a few frames very quickly and join up the members between. Okay, so that's doing very simple frames like so. The other method of working involves some little macros that we've done here, these little frame generators. So, as I said to you before, they're multi-bay, grillages, trusses, portals, trusses and girders. So what we do is pick on the one we want. You've got here numbers of bays, so we could have 3 bays of 8. If you want to, you can vary the pitch, by the way. And then you've got the member type. You've got the height here. Let's have a couple of 4 meter bays in height with some UCs going across. And then depth, 1 bay of 8 or 6 or whatever you wish. There we go. You can vary it. And off we go. So let's make that 6. There we go. Now these options here are for putting in our panels. So these aren't fine element plates. They won't be analysed, but they're ways of giving rigidity to a bay, or for you to then apply loads and transfer the loads from the floor onto the frame. They can be vertical or horizontal. So I'm just going to put a floor in here and create the frame. So let's just pop that down. Any grid here, so I'm just going to put in at 0, like so. There we go. Very simple. So we've got supports on here. The generator did that. That's using this quick support. I haven't shown you how to put the supports in yet, but let's pretend there's not one there. Quick support. We've got fixed, pinned, roller, all different types here. So just choose the one you want and where you want it to go. And again, like I've shown you before, if you highlight the member or members, you can go into the property of that particular type of support and say, right, I want to vary this. We could now put in, being vertical, we could put a spring in there. So we could do something sitting on the ground, for instance. There we go. Now these panels are very useful. As I say, they're loading panels really, and they provide a rigidity so that you don't have to put cross bracing in to have a rigid frame. You can see here the option to do that. You can make it a rigid plane. We can give it a property and a thickness because it's got its own self-weight. And you can give it a load distribution scheme, so you can say if it's 1-way or 2-way. And you can put panel loads in. So they can be quite complex, not just uniform. You've got create point load, line load, patch load. All you do is choose your type of load, what the value is, and say create and close. What happens then is when you run this, it will distribute that uniform load to the trapezoids, and you'll see that on the frame. So there we go. One other thing I want to show you is bringing in DXF. So let's go to Import, DXF, and we can find DXF file that's suitable here from my collection. We've got a little end bay here, and I'm just going to pop that on the end. Now, as is usual, it's not come in anywhere I can hold it. See, the mouse I've got it by isn't suitable. So right-hand click, choose a new mouse point to hold it by, and then pop it onto there. There we go. So we've joined two frames together. One is done by the program, and then the horrible bit's been done with DXF. Just saves, again, a bit of time. We can turn off those joint labels. Now, one of the things I want to make sure of is there's no duplicate nodes. A clever trick here is to go into relabel, and the program actually gets rid of any duplicate nodes for you, so everything's clear. And then we just need to add in quick member here a couple more supports. And bottom, there we go. That's it. If you want to we need that other panel. Look, it's missing from the bit we just brought in. So all we have to do is window round where the panels should go. That's chosen all the surrounding members. And then we go up to automatic panel, OK that, on she goes. To put the load on there, we go to properties of this one. And we had 3 before. Similar value, create, close, close. And then we can go into the analysis and run it. There we go. So that's the loads shown distributed. We can go up to the graphical results. There's the bending moment, shear force diagrams. Maybe a bit clearer if we turn the loads off and turn the rendering off. There you go. So we've got the moments, and we can make the numbers a bit bigger. There we go. Actual loads, labels, shear moments. There we go. Very simple. Different ways of doing things depending on which level of modelling you're doing, but all the same, quite versatile. Okay. So to finish off, I thought I'd just let you see some examples of projects that we've got from clients or that we've developed ourselves in-house. So you can see what variety of structures the CAD's A3D Max program is capable of. You can see here, top left, the 3-story steel frame building. It's a typical commercial unit. To the right of that, you have a staircase in steel. And below that, a grillage of concrete beams. These can be linked to CAD's RC Beam Designer, in fact, and in subsequently to the CAD's RC for automatic detailing and scheduling. To the right of that, there's a temporary works frame. You commonly see these propping up facades. Bottom left, some scaffold frames. This is a 3D roof, and then a 2D section through a roofing system here. Center bottom, it's a small stand. Then a portal frame on the right at the bottom. This is, the reason I put this here is that this isn't a standard portal frame where it's the same elevation all the way through. It's actually L-shaped in template, in footprint, so not suitable for things like portal frame programs typically. And then above that, I've got a sort of lightweight structure here, mezzanine floor. There we go. So if you want to find out more about the program CAD's A3D Max, just give us a call on the number below here, or contact us at sales@cads.co.uk, and we'll get back to you. Thank you very much for listening. Enjoy the rest of your day. Bye-bye.